Welcome to episode 9 of the design series, creating a custom computer case for a NAS with SOLIDWORKS xDesign. In this series, we're transforming standard PC components into a fully functional network-attached storage with a 3D printed case. Don't worry if you've missed previous episodes, links are in the description below. In the last episode, we tried to finish the design with remaining panels in plexiglass, including the panel that will hold solid-state drives, but we found some issues. So in this episode, we will see why so many industrial companies make prototypes even when they have the most powerful CAD software. Spoiler alert, it's not because of the CAD software. First, I need to be sure I don't forget anything, so I use an app provided with xDesign called Issue Management, where I already gathered some of the issues I faced when I assembled my case. Here I add the one about missing room for SSD cables, and I jump to the main issue, which is fitting between structural parts. Some crossparts broke when I tried to assemble the case. There must be a dimension issue, so I measure all fittings and realize some of them have a clearance close to 0. I made a wrong math with offsets. Okay, let's change all fittings to a rounded dimension, for female fittings 14 or 16 millimeters, and an offset dimension for male fittings 13.8 or 15.8 millimeters. Remember, you need a clearance of 0.1 millimeters on each side of a 3D printed fitting when printing PLA in FDM. Once I have added how I solved the problem in issue management for future reference, it's now time to 3D print new fitting parts, corners and crosses, then new bars when needed. As explained before, I couldn't quite fix SSD panel because of cables I didn't take into account when designing. So I will solve this issue by making a recess in this middle bar. This is not a bar that will be loaded the most, it's just there for rigidity and fixing panels. So there should be no issue if I remove some material. As first prototype was strong enough, I decide this will be okay. This is the kind of assumptions you need to do all the time. However, for critical ones, you can still check your assumptions with the simulation app. This is not the goal of this video, but it exists. Here I remove half of the bar width, with some angles to smooth efforts. Of course, I add fillets to remove sharp edges. And I leverage xDesign Fillet Assistant to select relevant edges faster. Part is done, I just make sure it's a new instance different from other side of the case, and I mark the issue as solved. Again, this is printing time. Another issue I noticed, the power cable attached to the motherboard is too close to front middle bar. With power cables you don't negotiate, you don't want to start a fire. So I will also create a recess with the same shape, but smaller this time. This is not recorded here, but I added a fillet, no sharp edge with power cables for same obvious reason. Again, this is printing time. Once it's 3D printed and assembled in next episode, power cable has enough room and I can sleep better. Last problem I will tackle today is the bottom of the case. In a NAS, the most important, expensive and heavy parts are the hard drives. So this is important, they are safely attached to the case. With former version, bottom plates didn't look good, so I decided to first increase the number of mounting holes for bottom plates, but it was still not strong enough. So this time I will increase strength, let's say. More seriously, starting with doubling plate thickness, then I measure clearance under hard drives so I can build without risk. I will start with some changes on one part to add thickness where drawers are attached on the plate. To do that, I create a sketch with several rectangles. I trim entities, add a couple of dimensions. I check sketch degrees of freedom by moving a corner. Some adjustments are needed when you trim because relations may disappear with entities you just trimmed. It makes sense. I center rectangles from holes with usual trick, aligning vertically on middle points, and I create the boss. And a little more thickness, by the way. Then I create a lip that will increase contact surface with the other part and help centering them together. I add a couple of dimensions to position lip properly and some clearance for correct fitting. Yes, I can learn from my mistakes, sometimes. I will finish design with some strong fastening solutions. 2 bosses with 2 screws each. This time bottom parts will not move at all. So I create first boss. Of course I forgot again to deactivate reference geometry when adding fillets, so I have to revert back to plain arcs. Then I add a line to hold circles and I add middle relations to center them. Once I have added solid geometry, I focus on clearance for nuts. This will help fastening screws without having to use too many tools in small places. I create a quick linear pattern of boss on the other side and I add fillets on all relevant edges. Please note I didn't pattern nut recess because it will be on the opposite part. So chamfers are the right features for this side to host my countersunk bolts. I check bosses don't clash with drawer. And under 19mm that's okay. Now I can take care of the other bottom plate. I create a sketch aligned with opposite part and add mirror and equal relations to position them with same dimensions. I also create a jog to host the opposite lip with an offset, and I add same thickness than the other part. Stability is key for my hard drives. I also forgot hole contours in my sketch, easily corrected. I fast forward creating bosses aligned with opposite ones and finish with nut recess. Again, I create hexagons with dimension I know, 6mm, and make sure I add a relation and not a second dimension. Once cut is done, I can move to the other boss. Here I need some chamfers for countersunk bolt heads. Parts are finished, I can check my assembly is up to date and save it. I can also mark the issue as solved with the solution I chose. This is printing time for bottom plates. They already look far sturdier than before. In the next episode, I will continue solving prototype issues, including some that just made the NAS impossible to use. And finally, I will try to have a final assembly that works. Will this time be the one? In the meantime, there will be some manual work, if I can find where all the parts fit. If you want to create your own models for a 3D printer, check out SOLIDWORKS for Maker's website to subscribe to xDesign for low price and start designing today. Thanks for watching and see you in the next episode.